ITER will be the world's largest experimental facility to demonstrate the scientific and technical feasibility of fusion power. 30 meters in diameter and nearly as many in height, the ITER Tokamak will house a large number of subsystems and components. The size and weight of the major components, the tiny tolerances for the assembly of major systems, the diversity of manufacturers, the tight schedule, all of these elements combine to make ITER an engineering and logistics challenge of enormous proportions. The principal assembly activities will be performed in the Tokamak building, where the ITER device will be installed inside of a partially embedded concrete bioshield. For the duration of assembly activities, the Tokamak building will be operated as a clean area and maintained at a constant temperature to avoid dimensional changes in the largest components. Pre-assembly activities will take place in the adjacent assembly hall. Assembly of the ITER Tokamak will proceed in a bottom-up fashion. First, the lower feeders for the ITER magnets will be put in place. Then, the base of the cryostat, the largest single component of the ITER machine, is lifted into position. The next components assembled are the lower cylinder of the cryostat, thermal shields, and the temporary support structures for colloidal field coil number 6, the smallest of the set of 6. A set of spare pre-compression rings are the next in line, together with the central support structure and the 18 gravity supports for ITER's huge toroidal field coils. Thermal shields that will protect the steel support structure are then attached. And finally, colloidal field coil number 6 is lowered into the pit, followed by PF coil number 5. In order to prepare for the arrival of the pre-assembled vessel sectors, the inner support column, the work floor, and the 7 beams are put in place to stabilize the structure during the assembly phase. While the cryostat is being assembled in the Tokamak hall, parallel activity is in full swing in the assembly hall. It's here where the sub-assembly of the 9 40-degree sectors is being prepared. Each set made up of a vacuum vessel sector, the surrounding thermal shields, and 2 toroidal field coils. In order to successfully maneuver hundreds of very large Tokamak components into position, a very precise made-to-order set of tools is currently under construction. A special sub-assembly tool will suspend each of the 9 sectors of the vacuum vessel from its top, install associated thermal shielding, and rotate 2 toroidal field coils into position. This procedure will be repeated consecutively to achieve 9 sub-assemblies, which will be transferred into the Tokamak pit for the final sector assembly. The lifting system will be comprised of a pair of independent bridge cranes, mounted on rails that run the entire length of the Tokamak and assembly halls to form a continuous 175-meter-long crane bay. Working together, the 4 375-ton main hoists will handle loads of up to 1,500 tons. With more than 18 meters height, the central solenoid, the magnet in the center of the machine, will be the tallest lift of assembly operations. The heaviest single load will be the base of the cryostat, which weighs in at 1,200 tons. In some cases, components standing 20 meters high and weighing hundreds of tons will have to be maneuvered into position within tolerances of 2 to 3 millimeters. The accurate alignment of the Tokamak components, particularly of the magnet system and in-vessel components, is essential to the successful operation of the machine. Assembly sequences have been planned with this in mind and will utilize sophisticated optical metrology techniques at each step of the assembly process. In all, 161 different types of custom tools will be required to assemble, lift, and finally maneuver ITER's supersized components. The tools will have loading capacities that vary from 500 tons for the upending tool that will turn vacuum vessel components from horizontal to vertical, to 1,500 tons for the heavy lifting tools, used to lift the sub-assembled sectors into the tokamak pit for final assembly and welding. There, the largest purpose-built tool, the in-pit assembly tool, will grasp all 9 sectors together, 3,800 tons, in order to align the vessel structure. The complete assembly of the ITER machine will take about 4 years. Following main assembly and alignment of the vacuum vessel, the second assembly phase, the installation of in-vessel components, will proceed with specialized remote handling devices.